Pentagon's HyCAT program tests one of the fastest aircraft ever built. The U.S. Defense Innovation Unit, the Pentagon office tasked with pulling commercial technology into military use faster than traditional defense contracting normally allows, announced that it completed a successful unmanned stores separation flight test with Hermes, an Atlanta-based hypersonic aircraft company, as part of the DIU's Hypersonic and High Cadence Airborne Testing Capabilities Program, known as HyCAT. A stores separation test verifies that an aircraft can safely release an external payload, whether that eventually means a weapon, sensor pod, or other equipment, without the object colliding with the aircraft or destabilizing its flight, a test milestone that matters enormously for any aircraft eventually meant to carry and deploy munitions rather than simply flying as a research platform. Another huge HyCAT milestone, a successful unmanned stores separation flight test with Hermes. This was only the program's fifth flight since the spring. Tests like this usually take years. We're moving 4x as fast, the Defense Innovation Unit said. That pace matters because hypersonic flight testing has historically been one of the slowest, most expensive corners of American military aviation, constrained by a scarcity of wind tunnels, specialized flight test ranges, and the sheer engineering difficulty of building anything that can survive sustained flight above 5 times the speed of sound. HyCAT exists specifically to break that bottleneck by tapping private sector hypersonic startups and their own investment capital rather than relying entirely on traditional Pentagon-funded test programs, a model the Defense Innovation Unit has argued can deliver flight data years faster than the conventional acquisition process typically allows. The aircraft behind this specific test, Hermes Quarterhorse, is an uncrewed, quarter-scale test vehicle the company built specifically to mature technology for a future full-size hypersonic aircraft. Quarterhorse runs on Hermes Chimera engine, a turbine-based combined-cycle propulsion system built around a modified General Electric J85 turbojet core, an architecture designed to let a single engine transition from conventional turbojet operation at lower speeds into a different propulsion mode as the aircraft accelerates toward hypersonic velocities, avoiding the need for separate engines dedicated to different speed ranges. Hermes reported that Quarterhorse reached a top speed of Mach 1.21, or roughly 930 miles per hour, 1,497 km/h, during a flight earlier in 2026, and the company has stated a goal of pushing the aircraft's flight envelope to Mach 3 by 2027, a speed nearly 4 times faster than a commercial airliner typically cruises. DIU first brought Hermes into the HyCAT program in November 2023 through a contract worth $23 million to demonstrate propulsion, thermal management, power generation, and mission system technologies that could eventually feed into future Pentagon aircraft programs. That relationship expanded significantly in May 2026, when Hermes announced a much larger $159 million contract under which the company will continue flying Quarterhorse over the coming years and share flight data with DIU, the Air Force, and the Navy to inform future high-speed military aircraft concepts. Hermes CEO Ajay Piplika has previously framed the company's HyCAT work as a deliberate bridge toward an operational military aircraft program rather than a pure research exercise, tying Quarterhorse's test flights directly to a planned uncrewed successor called Dark Horse. Hermes describes Dark Horse as a future military hypersonic aircraft the company intends to eventually mass-produce, a strike or reconnaissance platform that would apply the propulsion and structural lessons learned from Quarterhorse's flight tests to a combat-relevant vehicle rather than a purely experimental one. Analysts have previously pointed to potential roles for that kind of high-speed, uncrewed aircraft alongside programs like the Air Force's Collaborative Combat Aircraft Initiative, or as a standalone strike or electronic attack platform, according to Air Space Forces magazine. The stores separation test represents a specific and consequential step along that path, since an aircraft capable of hypersonic flight is not automatically capable of carrying and safely deploying a weapon or other external payload at those speeds. Aerodynamic forces at high subsonic and transonic speeds, the range Quarterhorse currently operates within, can behave unpredictably around a separating object, and a poorly understood release event could send a dropped store tumbling back into the aircraft rather than falling cleanly away, a risk that grows more severe as speeds increase toward true hypersonic conditions. Successfully clearing that test at Quarterhorse's current speed builds a foundation of validated data that engineers can use to model and eventually test the same maneuver at faster speeds as the program progresses. HyCAT has moved quickly on multiple fronts beyond Hermeus this year. The program notched its first flight in February 2026 when Rocket Lab's HASTE suborbital launch vehicle carried Australian company Hypersonic's DART AE testbed to speeds exceeding Mach 5 in a mission DIU called Cassowary VEX, gathering propulsion, trajectory, and vehicle data under genuine hypersonic flight conditions. DIU has also pursued a second program phase, HyCAT 2, partnering with companies including California-based Nextrack on guidance, navigation, and control technology meant to integrate onto these test vehicles going forward. Part of a broader strategy to build out not just the test aircraft themselves, but the surrounding technology ecosystem those aircraft will eventually need to operate as combat-relevant systems.